Hi guys, this video is going to show you how to solve the three gas law problems involving two variables. We got Boyle's, Charles, Gay-Lussac's law. Each of them will have two different variables, pressure, volume, temperature. You'll be given three numbers in the problem, solving for the fourth. For the particle diagrams on pages 5 and 6, you'll need to look back at the PDF on the Schoology assignment. But we're going to do the calculations here. With these, when you read the problem, we've got conditions at separate times. They should be on the same side of the equation, but what you call 1 versus 2 does not matter. So we're starting with Boyle's law, pressure and volume. We know that pressure and volume are inversely related. As pressure increases, volume decreases, and vice versa. So with these ones, looking at this first problem, we've got 10 liters. Liters is a unit for volume. And we have liters there. And then this isn't a number STP, but that's going to give us our pressure. So it doesn't specify what unit we have to use for pressure. When I have the choice, I'm always going to use atmospheres because the numbers tend to be very close to 1. So we had 3 sig figs for the other ones. I'm going to match that. So with these, I didn't assign 1 versus 2. It says in the problem occupied, so I'm going to say these are the initial conditions. So this is going to be V1, and this is P1, and then this one will be V2. If you called that V2 and P2, that would be fine, as long as these two, which are at the same time, are on the same side of the equation, and that's on the opposite side. So we're going to plug in the numbers into this equation, then do the algebra to find the fourth. So we said we know P1 and V1. So this is P1 times V1, 1 atmosphere, that's a 0, not a 6, times 7.6 liters equals P2, that's the one we don't know, times 10 liters. And we're trying to find P2, so to get that by itself, we're going to be dividing by 10 liters on both sides. And when we plug that into the calculator, 1 times 7.6 is 7.6 divided by 10 is going to be 0.76. And we're going to follow our sig fig rules. So all these numbers had 3 sig figs, so our answer should as well. So 0.760 atmospheres would be our final answer. Now with these problems, you can use any units as long as they match on both sides of the equation. So you don't have to convert your pressures to atmospheres every time. You can use kPa, you can use mmHg, you can use milliliters, as long as they're the same on both sides. That's the only thing that matters for Boyle's law. Now, I only gave one example problem here because solving for volume, same algebra. For the other two, we're dividing, so I did 2 problems. All right, so that's Boyle's law, pressure and volume. Next one is Charles' law. This one is volume divided by temperature. The values, volume and temperature, increase and decrease together. For all gas law problems that have temperature, you need to convert it to Kelvin. We usually measure in Celsius, so we're going to be adding 273. So with this one, reading through the problem, we've got degrees Celsius. Those are our temperature numbers. It says increased, so I'm going to call this T1 and this one T2. And then we have a volume. Liters are our volume. It says initial volume, so that's when it was at 23 degrees Celsius, so that'll be V1. And we're trying to find V2. So before we plug this into the equation, over on the side here, for this one I'll show the math. So we're going to do 23 degrees C plus 273, and that gives us 296 Kelvin. And then for T2, we've got 45 degrees C plus 273. That gives us 318 Kelvin. So these are the numbers that we're going to plug in. If you try to plug in Celsius, you're going to get the wrong answer. Sometimes you're dividing by a negative. You can't have a negative volume, so that doesn't make sense. It has to be based on Kelvin because that's the one that's based on actually the speed of the gas particles. That's what matters. Okay, so this one, the equation, I'm going to write this over here because that doesn't show up too well. V1 over T1 equals V2 over T2. So we're going to take the first volume. We've got 2.33 liters over the 296 Kelvin. That's equal to V2, that's the one we don't know, over 318 Kelvin. And because we're trying to find volume by itself, that's on the top, so we need to multiply by 318 on both sides. And I'm kind of out of space here. Put it right here. So V2 comes out to be 2.50 liters. That's our answer. Okay, so solving for volume is the easier one. Temperature is the one that gets people tripped up because you're going to be solving in the denominator. For that, however you do your algebra, you can do the cross multiplication, that's fine. So this one, we see at STP. STP is how we always sneak the numbers in for you. So we're using Charles' law. We only need temperature. So that means we'll call this T1. That'll be 273 Kelvin. That's our conditions at STP. And this one will be V1. So we have milliliters. That's fine. We don't have to switch that. Our answer at the end, we want in Celsius. We're going to solve for it in Kelvin, and then we'll subtract at the end. And then this number here is V2. So for this one, we're trying to find P2. So we'll plug in our numbers into this equation. V1 over T1 equals V2 over T2. So our V1 was our 750 milliliters over 273 Kelvin. And we're going to, oh, I didn't even notice. So these aren't matching. Milliliters and liters should match. So since I already wrote down milliliters, 1 liter is 1,000 milliliters. That's what we'll plug in on top. And then we don't know T2. So with this one, what you don't want to do is divide by 1,000 on both sides, because what that will do is get you 1 over T2, which is called the inverse. We want T2 by itself. So for this one, you're going to have to get this back on the numerator. So you can use that TP method, cross multiplication. So we got 750, I'm going to lose my units here, times T2 equals 1,000 times 273. And then we divide by 750. And that gives us T2 of 364. So for this one, we want to keep, technically we should only keep 2 sig figs, but I'm going to keep 3 for now. So 364 Kelvin. And because the problem asked for Celsius, we're going to subtract. If it doesn't say anything, leave it in Kelvin. That's totally fine. But because we want Celsius, we're going to subtract 273. And that would give us 91 degrees Celsius. Now, if we were really following sig fig rules, we should round this one to 2 sig figs, which would be 360 Kelvin. And then when you subtract, you get 90 degrees Celsius. That's actually the best answer, but for this one, we're just going to round to a whole number. Okay, so that's Charles' law. And then our very last one is Gay-Lussac's, which is solved basically identically to Charles' law. You're going to have pressure divided by temperature. As temperature increases, pressure increases as well, just like the Gay-Lussac's law, or sorry, just like Charles' law. you need to have your temperature in Kelvin. So for this one, we've got original pressure. I'm going to start here. That's going to be P1. And it says heated from 15 to 90 degrees Celsius. That's our temperatures. So I'm going to call this T1 and this T2. And we're going to switch both of those to Kelvin. So 15 plus 273 gives you 288 Kelvin. And 90 plus 273 gives you 363 Kelvin. So these will be the numbers we plug in. So it's going to be pressure 1 divided by temperature 1 equals pressure 2 divided by temperature 2. So we're going to have 3.0 atmospheres over 288K equals P2 over 363K. Just like our first Charles law example, we're going to multiply by 363 on both sides. And that gives you a P2 value with 2 sig figs because that atmospheres. That would be 3.8 atmospheres. So that's a pretty big temperature change. It didn't bring the pressure up that much. You got to change temperature a lot to make a difference. All right, and then our last one, we have one number, but we've got STP. This time we're going to use that for both pressure and temperature. So for this one, we'll call this P2. Our pressure should match the units that we had on the other side, which is torr. So at STP, pressure will be 760 in torr from your reference page, and then temperature is 273. So this one, we know everything except T2, so we'll plug these in. So we've got 770 over, I'm going to do this backwards, P2, sorry, T2. And just like our second Charles law example up here, we've got temperature in the denominator, so we want to make sure we're not just dividing by 770, that we do cross multiplication or rearrange it so that you get T2 on top. So when we do that, we've got 760 T2 equals 770 times 273 divided by 760. And we get T2 equals so this one will want 2 sig figs, so that would be 280. Calculator says 277. We would want 2 sig figs. Now this one doesn't say Celsius, so we're just going to leave that in Kelvin. That would be, 7 degrees Celsius, but Kelvin is fine. That would be our answer. I forgot to underline this one. Okay, so those are the 3 gas laws. You'll use that to complete the next AL assignment.